So problem number 22 of the MIT integration be qualifying exam 2013, which is the indefinite integral of the square root of 12 minus 3x squared. So let's see how we may be able to solve this problem. So this is our problem. Let me write it over. The indefinite integral of 12 minus 3x squared. One thing we could do is pull out square root 3, and then you're left with 4 minus x squared. So we can use a trigonometrical approach. Let's begin with the trigonometrical approach. I would like to substitute this with let x be equal to 2 sine theta. And what that means is that dx d theta would be equal to 2 cos theta, right? And therefore dx could be substituted off with 2 cosine theta d theta. So this is an important evolutionary step that we've gotten ourselves to. So given that we have our problem as that, then it becomes 3, the integral of 4, x becomes 2 sine, so it becomes 4 sine squared theta, and the x we found to be 2 cosine theta d theta. So pulling the square root of 4 out and also this 2, we definitely come to 4 root 3 1 minus sine squared theta cosine theta. So 1 minus sine squared theta is cosine squared theta, square root becomes cosine theta, so we come to the integral of cosine theta times cosine theta, which is simply cosine squared theta. That's our integral. We know that cosine 2 theta is the same as 2 cosine squared theta minus 1, and therefore cosine squared theta is 1 plus cosine 2 theta divided by 2. So we're going to use this identity, which means that our integral now becomes divide by 2, 1 plus cosine 2 theta. So it becomes 2 root 3 integral of 1 plus cosine 2 theta, right? And this evidently is 2 root 3 in bracket theta plus a half of sine 2 theta plus c. But we had initially said that x was equal to 2 sine theta, right? And so since sine 2 theta is the same as 2 cosine theta, this part here, and also from here, if x equals to 2 sine theta, then it means that cosine theta is the same as for this specific part is x over 2 squared is equals to sine squared theta Therefore cosine theta is equals to the square root of 1 minus sine square theta, which is 1 minus x squared over 4, which is a half times 1 minus x squared. So therefore our sine to theta becomes 2 times a half square root of 1 minus x squared. Sine theta is x, so this becomes x square root of 1 minus x squared. So since our solution came down to 2 root 3 theta plus a half sine 2 theta plus c, and we found that x is equals to 2 sine theta, which means that theta is equals to arc sine of x over 2, right? And also we found that sine 2 theta is the same as x square root of 1 minus x squared. So rather, our interesting problem minus 3x squared is the same as 2 root 3 in bracket plus of theta. We have arc sine of x over 2 plus half x 1 minus x squared plus the integration constant. And that, ladies and gentlemen, is where our problem stops. Thank you. Until next time. Bye-bye.